This video is about stereochemistry and biomolecules. So the keyword in the question is the difference between enantiomers. And the concept of this question is similarities and differences between enantiomers. So here we have an example of a pair of enantiomers. In this case, it is D-aniline and L-aniline. So we can first talk about the similarities. So we know that to have enantiomers, they need to have chirality. In this case, is a chirocarbon, or we can call that a stereogenic center. But we also know that they have the same number of each atom, or the same type of atoms, and therefore they have the same molecular formula. The next similarity is that they have the same functional group. So in this example, it's the carboxyl group right here. That means that they will react chemically very similar. So they have the same physical and chemical properties. Now we can discuss the differences. So obviously we can see that they are mirror images of each other and they are non-superimposable. And so that means that each of the atom or group of atoms are positioned differently around this chirocarbon. And to put it in words, it is the position of atoms or group of atoms around stereogenic center. And the second difference is its direction of rotating plane polarized light. And this concept will be explained in further detail. So what it means to have plane polarized light is that because light naturally doesn't have a specific direction and it's all over the place. So it will be put in a polarizer, and once it goes through that, all light will be uniform in one direction. And this light right here is called the plane polarized light. So using this light, if we were to put in a sample of molecules, which includes both of the enantiomers, there will be two sets of results. So one portion of the light will end up in this direction, and the other will end up in the opposite direction. So let's compare to the original light. So we can see that half of the sample has been rotated in a clockwise direction, and at the same angle, the other half of the sample has been rotated in the anti-clockwise direction. So enantiomers, or any chiral compounds, have the ability to rotate light. And so a pair of enantiomers have the ability to rotate light at the same angle, but they will rotate light in opposite direction. So one will rotate light in a clockwise direction and the other anti-clockwise direction. So if we were to go back to our question, we're looking for the differences between enantiomers. So first one is physical property. We know that is a similarity, so we can cross that out. The second one is position of atom or group around stereogenic center is indeed a difference. And lastly, direction of rotating plane polarized light is also a difference. So our final answer is C.